Bristol Community College, Mathematics with Dan Avedikian, Math 060, Topics in Developmental Mathematics, Section 2.7, Problem 9. This is Section 2.7, Problem number 9. It says find the least common multiple for the numbers 24, 48, and 128. So what makes this problem a little different from the previous problems in this homework section is that we have three numbers to find the least common multiple for. But it's really the same process. What we want to find is the smallest number that 24 divides into evenly, 48 also divides into evenly, and 128 also divides into evenly. So once you get into three numbers, it becomes very tough to do a trial and error or to make a guess. It's really beneficial to just do the prime factorization and do the process the way we do it to find this. So start with 24, do the prime factorization. So 24 splits into 4 times 6. Among other things, you'll get the same prime factorization in the end. The 4 will split into 2 times 2. The 6 will split into 2 times 3. And now at this point, everything is prime. So those are the primes that multiply to make it 24. That's the prime factorization. So underneath, I'll put 2 to the third times 3. Again, where I have a repeated prime, like the 2, I use my exponent. Next, do the 48. So 48 would be 6 times 8. The 6 will split into 2 times 3. The 8 will split into 2 times 4. The 4 is not done. The other numbers are. So 2 can come straight down without splitting. 3 will come straight down without splitting. I have a 2 again, comes straight down without splitting. And then the 4 can split, 2 times 2. Now at this point, everything is prime. So I have 1, 2, 3, 4 2's and a 3. So that would be 2 to the 4th power times 3 for the 48. That's the prime factorization of 48. Now 128, that's fairly big. So I don't have any room to go underneath any further. So let's bring it up here, 128. I can see that it's even, so it's 2 times 64. The 2 is done, it'll come straight down. The 64 is 8 times 8. And at this point, I can see everything's going to come out to be a 2. So the 2 that I start with comes straight down, it won't split anymore. And each 8 will split into 2 times 4. And then the 4s I can split again. So I have a 2 that comes straight down, another 2 that comes straight down, the 4 that splits 2 times 2. There's another 2 that comes straight down, and finally there's a 4 at the end that splits into 2 times 2. So how many 2's? Everything's a 2, no other primes. So 1, 2, 3, 4, 5, 6, 7. So 128, the prime factorization is 2 to the 7th power. So I have the prime factorization of each number. There's 3 of them instead of 2 for this problem, but it's the same process. Find the prime factorization of each number. There it is. Next step, write a list of the primes that are used in any of the prime factorizations. So I have 2 and 3, really is all I have. And then where I have exponents, I want to choose the largest exponent. So for the 2's, I have 3rd power, 4th power, 7th power. Those are my options, and I want the largest. Well, 7th power is bigger than 3rd power, 4th power, so that's the exponent I take. 3 shows up in 2 different spots, but both times it's only to the 1st power, so my answer stays to the 1st power. So I have to multiply out 2 to the 7th times 3. Now, fortunately, I don't really have to do 2 to the 7th again because I have it here. I know 7 2's multiplied together multiplies to 128. So when I multiply it out, I can really just go 128 times 3. That's a little bit big. I could probably figure that out without writing it down. But let's just take the, half a minute or so that's required and just write it down and do it out. So 3 times 128. I'll start with 3 times 8 is 24. Write the 4, carry the 2. 3 times 2 is 6. 6 plus 2 more that we carried. 6 and 2 is 8. Nothing to carry this time. And then 3 times 1 is 3. So my final answer comes out to 384. Now what that means is 24 will divide into 384 evenly, 48 will divide into 384 evenly, and 128 will also divide into 384 evenly. And there are no other values smaller than 384 that all 3 of these numbers, 24, 48, and 128, will divide into evenly. There are bigger numbers than 384 that they'll divide into evenly. 384 is the smallest. And again, why? So what? Well, the reason why is if you had a fraction problem with 3 fractions and you needed a common denominator, and you had 24, 48, 128 with denominators, 384 would be your lowest common denominator for those fractions.